Okay, just wanted to do a follow-up on the video I made in the middle of the night. I just read this second paper by this Greek mathematician talking about the Fourier time frequency uncertainty in relation to the Heisenberg position momentum uncertainty. And he's basically pointing out that he refers to David Bowman-Yakir Aronoff stating that time is not observable and therefore time is a parameter. And so time's not an operator, because in quantum physics an operator is unobservable from the measurement. And so this means that in terms of the mathematics, it's much preferred to have a definite time and an indefinite energy when you compare the time-energy uncertainty. And so what that means is that the phase as time is actually the Planck's constant as a distinct period of time. And what Basil J. Hiley is pointing out is that, in fact, the time is not an external parameter, but the time is an operator, even though time is not observable. And what this means is that you have this inherent noncommutative time of the future and the past overlapping. And so the non-commutativity is the basis of the time frequency uncertainty. And what Fourier's original point was that, as this Greek mathematician explains, is that frequency has to repeat by definition. It has to be periodic. And so you can never use the calculus of an instant of time at zero. So it has to be 1 or greater than 1 based on the period of the circle as a wave. But in terms of linear frequency, you have the Pythagorean ratio of time and frequency being inverse. And that's when you get into the music analysis that I've pointed out that also does not allow a value of 0 for the definition of time and frequency because of the inherent non-commutative music of pitch. And this is, of course, Alain Kahn also points this out, but he doesn't go into the music details. But so Basil J. Hiley's point is that this changes the definition of a photon, because when Einstein took Planck's constant to create the photon, it means that you can never measure the photon as a particle with rest mass, because it has to have a distinct time in order to have a uncertain energy. And so you have constant motion of the energy when they assume that the time is 0. But in fact, the time is never 0 because of this uncertainty, because of this non-commutativity. So the problem is that when Planck created his constant, he was assuming this periodic time so that he could cancel out the period of the time to create a distinct 0 of time while having the energy uncertain based on the speed of light. And so that's why you get this, you can never resolve relativity with quantum physics in terms of the speed of light. And so then what Basil J. Hiley is pointing out is that in fact you never have 0 time, and so you have this non-commutative, non-local time that's an eternal process, and so you can never have a symmetric rest frame, and that's why relativity is inherently wrong at its foundation. And he says it's ironic because if you're trying to measure the speed of light due to relativity, you would have a contraction of the wavelength or a increasing of the frequency, and that's why the photon itself does not experience space-time on its own terms. But obviously they're saying that, again, you can have this 0 point of time as a period, assuming a wavelength that is not observable, but it's a parameter. So Basil J. Hiley is saying, no, that's not accurate, that in fact time is an observable, but in terms of it being an operator, but it's not observable physically, so it's non-local and non-commutative. So this is where I step in and say, well, look, in music, you listen to time. So don't even forget about it not being observable as an external measurement. And it's proven that musicians can listen up to 10 times faster than time frequency uncertainty. So based on the time frequency uncertainty, it takes a certain amount of time to convert to frequency and vice versa based on what the frequency already is that you're trying to measure. So intuitively, obviously the more precise the frequency, the longer the time it would take to measure the frequency. But when you compare that with listening, what happens is that you get what they call quantum coherence, because you're able to convert to the frequency difference faster than would be allowed based on assuming a symmetric period of the time. So this is why this mathematician in Greece, that I emailed him. I think his first name is like Constantin, and his last name I haven't even tried to pronounce it. It's like Antonopoulos or something like that. So I sent him Basil J. Hiley's article about time being a moment as a non-local process and not ever a instant at 0. And So his research, they corroborate each other, and it's fascinating because everybody assumes that, the calculus is the foundation of science, and that the real number system assumes a symmetric definition of time as a symmetric spatial measurement, and that was actually from the wrong music theory that I've pointed out. And so you have this wrong foundation of science that quantum physics then rediscovered when Heisenberg was studying the discrete emission and absorption of light, and with the change of the energy of the photon. So that's how you're converting the energy to the change of the frequency of the light. And how does that relate to time? So you have this secret time from the future that's actually an anti-gravitational force, or a positive pressure, that's before matter exists because it's from the photon. And that's what you can access through meditation. So thanks.